Okay, welcome to the last talk of the last session of PyCon AU 2018. To close us out today, we're going to have Tennessee Leeuwenburg, and he's going to help us watch out for safety bandits. Let's give him a warm welcome.
Push on. Thank you for your warm welcome, everybody. For anyone who's read the abstract already, you've got the main thing that I want to get across to you, which is there's a tool called Safety and a tool called Bandit, and you should probably use them. And I was reflecting on how to make sure people remembered it, and there appear to be two main ways to get people to remember something. There's drama and there's repetition. And unfortunately for you, I've gone for repetition. So I've been thinking about how security is often represented. It's often represented like this. Has anyone seen a representation like this of security? I'm sure you all have. For those of you who work in a corporate environment, you might have seen a representation something like this. I was looking around. I think this is by far my favourite representation of security that I was able to find. Thanks to publicdomainpictures.net for many of my amusing memes. Okay, so security is a huge space. So anyone who happens to be new to the security domain, don't feel like these tools make you safe. Feel like they make you safer, but don't feel like they make you safe. So the things that we will be focusing on, zoom in on just the top left-hand corner of all of the things you should probably keep in mind when considering the security of your applications. And in particular, just two tools for just Python for those things which solve some of the problems relating to them. But they're very useful. They are probably like better than your average intern. So right? So that's kind of the level we're going here, because everybody loves a free intern. Okay, so security problems. So we need to a bit more detail. Okay, so there's a lot of lists out there. There's the top 4 and the essential 8 and the top 35 and the top 44. I've come up with a simpler list where there are essentially 2 types of security problem. Stay with me. There's problems somebody else made, and there are the far worse problems that you made. Okay, so these tools will assist with both of these problems. So we will return first to the problems that somebody else made. So there are lists on the internet of problems that somebody else has made. These things are called common vulnerability enumerations. This is a major Python library. It is used by the likes of Instagram, Dropbox, Quora, Spotify, Reddit, and YouTube. And this is not news, secret, exciting, and only very mildly overdramatic. But what it shows is that keeping on top of problems is very important. The reason that these major players manage to use a library like this is because, like all software, problems are found, but not like all software, here it's tracked and managed. The number of problems that you will find internally in your source code that don't show up on lists is enormous. But if you're not paying attention to the lists, someone else will be paying attention to the lists, and that may give you a very bad day. So let's look at how we deal with that. We patch things. We stay up to date. This is the Australian Cybersecurity Centre, currently becoming cyber.gov.au's Essential 8. Let's look at 2 of them. They're both patching. It sounds like it's pretty important. To be mentioned twice in the top 8 list of Australian recommendations is patching. So you see where I'm going with this repetition thing. So the tool for this, for Python, is Safety. Safety. It just sounds wonderful. So how do we use this package, and how does it keep us safe? So the first thing we could do is install an insecure package. Python comes with a specifically tailored insecure package that you can use for just these purposes, and then we are going to detect this insecure package with Safety. So you run safety check at the command line, and it tells you that you have an insecure package. It's not very complicated to use this tool. It's not very complicated to understand this tool. It is not something that everybody uses. I'm flummoxed by this. I managed to ignore its existence for many years. Nobody ever came up to me and tapped me on the shoulder at university or in the next team I worked in or at the team after that and said, by the way, there's a tool called Safety and it's incredibly easy to use and you should know about it. So I thought I'd just do that here. It's really not complicated. I feel almost embarrassed talking about it. I would call it the basics, except it's in fact not the basics, because the basics are in Dive into Python and Intro to Python in your university courses, and it's not there. It's not in the basics. It's just easy. So there we go. Part 1 of talk largely over. This is brought up by pyup.io, and if you have an open source package that you maintain in public and you have access to all these wonderful automated open source tooling like Travis CI and all GitHub and all of those wonderful doodads, you can turn this thing on and it will email you and it'll check your merge requests and some configuration and so forth aside. It will take care of many of these things for you and it will do a pretty good job. Okay, problems you made. Okay, so how are we taught to think about problems we make? There's examples of very specific problems that we make, and then there's theories of how to consider security risks in general. And this slide comes from OWASP. They're an organization that talks about security a lot, and there's this process called threat modeling, and they have this not amazingly exciting diagram here. So fortunately, someone's made an exciting one. Okay. So this is a much more exciting diagram. So happily, what we can see here is immediately there are different kinds of threats. So Bruce Wayne is Batman, for anyone who doesn't know.
Spoilers.
Yeah, so Bruce Wayne is Batman, but the police don't know that Bruce Wayne is Batman. Okay, so there's a threat there. Now, not many of us have, dual identities that we need to maintain, or so I'd have you think. So what we have here is this example that his security threats are specific to him. Okay, so they're not necessarily the kind of thing that we all have to deal with. So this is how we think about weaknesses. So that's threats on the one side, and then in the middle there's protection. And then the attackers or the threat actors or the APTs or whatever word you want to use are going to try and find their way using vulnerabilities past the protection into our assets. There's a fairly straightforward way of understanding it. So when you're developing code, you may end up with a vulnerability, which is what safety would find, i.e. a specific actual problem in a specific product with a version that you're using, or a weakness, the kind of thing that leads to a vulnerability. So again, thanks to OWASP and MITRE and organisations like this, someone has done the hard and incredibly dull work of giving these boring names and numbers. So the key thing to do is to sit there and read all 200 of these, and then you'll be totally covered. I didn't do that either. So they are interesting though. So by the time you become a sort of senior level developer or something like that, these are generally things you should be like roughly aware of. There's obvious things like SQL injection. That's probably listed number 1, as it turns out. It's kind of a more specific example of generally untrusted user input. There's a bunch of things that relate sort of more to C, like buffer overflows and memory management and things that apply to how your actual CPU works and the kind of thing that we've been had presented to us as very exciting things called like Meltdown and Spectre and these amazing names like that, and not called whoops, I forgot or anything like that. So what I'm mainly getting towards here is the whoops, I forgot category of issue. So these are the top 10. So we've got injection attacks, broken authentication, sensitive data exposures, XML. So what you get is this sense that like almost nothing we use like is looking after us, when we're developing all that well. There's a lot of room for whoops, I forgot as the number 1. So Bandit. So Bandit is the thing that will help us with whoops, I forgot. Okay, so let's look at the ways in which Bandit helps us with these particular things. So for those of you who are familiar with how Python kind of runs on the inside, it turns your source code into an internal tree representation. That internal tree representation has enough of the things like the names of your functions and what's going on inside it that you can like search it and look inside it and introspect it and find out what things are called and what they're doing, etc. This is what Bandit does. So some tools will just be like 100% straight syntax. so they won't really understand the structure of your program. They'll just go, oh, you know, creating a web form and not having a handler that does import bleach looks bad, and I think they're all happening in the same file. This will actually go, where does the calling go to some degree? And then these things here all load that thing called an abstract syntax tree into memory, and then they'll basically grep through your syntax tree and go, this bit looks questionable, to greater or lesser degrees of quality, which is always the issue with these tools, is that frequently it's down the lesser end of quality, but sometimes it's up the top end of quality, and often they're very useful. So most of the time when I've run Bandit over a code base, it hasn't just been silence. There's normally something in there. It's frequently stuff in the admin scripts, and you go, oh, that's okay, really, only an admin user should be using them. But hypothetically, should you connect them to some untrusted user input, they would be very, very bad. So you don't get entirely away from actually having to understand your code, but they give you, if you get these things popping out in areas of your code where they shouldn't, it's very telling. And if you were going to go like audit a new code base or something like that, if someone just like hands you 500,000 lines of Python and says, can you just like read this and tell me where the security problems are, this might be the kind of way that you would turn that into a more tractable exercise and not necessarily just flip the table at them. So let's have a look at some of the, so one of the ones that's decent is this one here where it's like sniffing SSL versions. So there are many reasons you might want to support a piece of known broken authentication, like you have a dependency on a system that is using known broken authentication, and you've surrounded it with like 9 layers of firewall, and only those two things are talking to each other, and there's a trust relationship in place, and you're like, you know what, broken authentication is fine. But there are situations where it's very, very bad. And these will highlight to you whether or not you're using known broken authentication, or perhaps more accurately, when the person who built it 4 years ago was using good authentication, which became broken, and nobody ever checked except the handy-dandy robot, which you've set up because continuous integration is fantastic and you're awesome like that. So here's another example of where it's picked something up that's been quite useful. This is real code that I've seen. It's not used in a context where the trust relationship is a problem. So what this is doing is passing in, someone has got a directory that they know about in their head. For some reason, they want some other computer to go list the directory. It is essentially for administration, which is why they would want to do something strange like this. And the particular issue here is that shell equals true parameter. So the potential issue there is that if you can get in there and do strange things to the environment variables, you might find you're not calling ls at all. You might, so this is not a talk on the specifics and nature and how all of these security problems like manifest. This is not like a penetration testing talk or anything like that. This is a developer tooling talk. So I'm not going to really go into how this could lead to an exploit in a very, very bad day, but it definitely can. And this is where Bandit's doing well. So if you've got these set up, caught it in CI, save production. Okay, these things are important, right? You know, these things turn up. When we look at those top 25 weaknesses or something like that, or the top, the CVEs and the top 25s, like they're the ones that are actually hitting production. And some of the things that are actually hitting production in the top 25, like there's some of these, like in big projects that many, many people use, the top 25 that people are like finding, reporting, starting a CVE process for, bothering to manage and discuss in public, are these ones. So again, none of this is rocket science. It's all pretty straightforward. The tools are a little noisy, so you'll have to get used to working out which ones to understand and which ones to turn on and turn off. But no one had ever tapped me on the shoulder and said, hey, by the way, you should just turn this on in your system and it could save you from having a very bad day. So, end of the talk, right? You know it's never the end of the talk when someone says it's the end of the talk. But wait, there's more. So what more is there? Like now you get to the point where you have to talk about this. Like say you've found some of these particular issues. You've audited your code base, you've got in there and you've gone, oh, there's a few issues, and I've fixed them. Are you safe? No, you're not safe. Now you have to go back to Batman's threat model. You have to go back to your big grid of all of the things you might have to worry about. You might need to know a bit more about all of these things. So I felt I really couldn't just give this talk and just stop at the end of here's what these tools can do, even though that's the bulk of it. So safety and Bandit. Okay, repetition. So all of these things, like safety and Bandit, really only protect you from, I don't know, like a quarter-ish of the static of things that could maybe theoretically be discovered by static analysis, and if you include code review in that, leave it at a quarter or something. That's a very random number. There are no statistics behind that number, and it's reasonable at dependency checking, except for the fact that not all libraries are going to be going through code review. Not like someone might find a vulnerability in a product, but no one's necessarily going to trace that all the way back to your particular library. They might, but they might not. So you might want to use that Bandit tool, for example, on all of the open source libraries that you're pulling in. If you're mirroring PyPI or something like that, or you're installing things that aren't on a frequently updated distribution, or you have legacy code sitting there in production that's 5 years old and like it's fine and nothing seems to have gone wrong, which is good, but you might want to just check now and again, like what's sitting there in your legacy in your supply chain. So I just want to draw people's attention, if they've come to this talk as a security newcomer, which all of us were, particularly sort of me until not all that long ago, what is the space of security that you need to worry about? And really it's bigger than one person. It's bigger than developers, it's bigger than development. A lot of the conversations around security often come from pictures of hoodies in the security industry and the security world, which has a very operations focus. But this is sort of what it is. So Microsoft have this thing called the Security Development Lifecycle. And I'm really impressed because they start with core training. So if you go and you run some of this on some of your code bases and you find a few things, you might want to consider step one of the Security Development Lifecycle and get some core training going. And it's pretty straightforward. This stuff is generally not rocket science. Again, I can't call it the basics, but maybe I can call it the foundations. You can save yourself a lot of trouble by doing the foundations. Where to go to help? So there's people type help. Like if you go back to your office and you discover, say, many of these problems and have a small heart attack and go, uh-oh, what do I do now? You might want to go through some of these kinds of escalations. You might want to find, maybe your team lead. Your team lead is on both the people and the learning side. But there are people in your organization who should know about this stuff. There are organizations who know about this stuff if your organization isn't all the way up to bottle on it. And there's a lot of learning you can do. I mean, there are whole careers in most of those boxes that I just described. So you really might want to get a consultant in who's familiar with all of these things if you want to. So that really is the end of my talk. So thank you very much for coming along.
We'll go ahead and take questions. Great. And remember, your question should be in the form of a question.
Hi. With a lot of these tools, I feel like there is one person in the team who understands it and the rest of them learn how to tell it to shut up.
Yes.
What is your experience with these particular ones?
So hopefully you can use a CI system to do double checking that people aren't necessarily doing. So if you're asking about what kinds of manual process can that person who understands them do, you can tell them you can tell the tools not to shut up again and find all the places where your developers have told them to shut up and have a human conversation about whether that was a good idea or not, and whether or not it turned out to be significant. It's often really hard to tell. So I have quite a lot of sympathy for people who go, oh, this is just the complaining part, the signal to noise is not there. Look, that's probably true. So some of these tools' strengths are not so strong in some areas. So I've got a lot of sympathy there. Eventually, the only answer is somebody's insight, whether it's that team leads or educating those people or watching the right presentations or maybe even contributing to the strength of some of these tools. There's not like a great easy answer, but there is a feedback loop. So tools like this can help you create the feedback loop. I feel like I successfully dodged the question.
Other questions?
What were the names of the tools again?
That's a really good question. I think I've forgotten already. Can anyone remind me what these tools were? Safety? Thank you very much.
Are there any other questions? Oh, whoop.
Were you aware that Bruce Wayne wasn't always the Batman?
I was not aware.
So one time Superman wore the Batman costume to beat up Bane.
Wow.
And I'll stop now.
Oh, I see one question in the back.
Hi, I know the pipenv tool has a command to check for out-of-date dependencies. Do you know if it's using safety or something else?
I do not know. No. It is? Well, that was Nick Coughlin, and I'll take his word as gospel.
So what can you do to reduce that signal to noise once you see it starting? Like, I just ran Bandit on my code base, and it came up with like 55 errors on a new project. Yeah. I skimmed through them all, and they were like low warning, and yeah, I can account for them. So what do you do next?
Well, if you can account for them all, great. I'm sure there's ways to go turn it off, usually with some kind of comment, which is normally the way. You can. I think that there's room in the world. I think most of it's going to involve software development. I think when these tools could all use about another 3 years of maturity on them and some engineering effort behind them. Until that occurs, make your file system and your modules layout match the threat model of what's going on in your code is probably the piece of advice I'd give, so that you can make sure that you're scanning the right places with the right level of paranoia for that particular piece of code. So make sure that you're targeting these tools in a directory by directory or module by module namespaced fashion, such that you know where your user-facing functions are and that they're not intermixed with things that have a different trust level in them.
Any last questions? Okay, great. Well, we have a gift for you. Thank you so much for your time and speaking.